So let's start with demo of Pandas, and here I'm creating a new notebook, and this notebook I will be renaming as Pandas demo. So let's start with import of Pandas, and we'll say import Pandas as PD, and we will say let's say pd.tab. We have so many methods again. When we do pd.tab, we have so many methods. We have methods related to the reading data, writing data. We have methods related to like processing data. So many things are there, but particularly we are interested right now into reading. So there are so many options of reading data. So one option is you can read from clipboard. You have option to read from CSV file, and you can read from Excel file. Feather is another format. FWF means fixed width format. GBW means Google BigQuery. HDF is another format. HTML another format. JSON, ORC. So many formats are there. So we are interested right now into read_CSV method. So I have chosen that, and I am showing you the documentation. So when we see the documentation of read_CSV method, you will see by default the separator is comma. So that's why it is comma separated values. But if you want to have another delimiter, the field delimiter, then you can override this separator and you need to pass it explicitly. In that case, let's say your file is tab delimited or pipe delimited, you have to pass the separator explicitly rather than relying on the default separator, which is comma. And then you can specify the path of the file, or you have so many other options like you can have a look. So this method is very matured and it has so many capabilities. So for the time being, I will get started with this. So if you are interested in learning more about read_CSV, just have a look at the examples given within this documentation. So let's start with this, and we start reading some data. So we have data in a file. This file is under the data folder. So we have data folder. If you go inside the data folder, we have a file user.tbl. So this file is pipe delimited, and there is a header also. And if you scroll down, you will see there are how many records? There are 900 plus records. If you scroll down further, you will see there are 944. So one is header, so you can say 943 rows are there, 943 records are there. So I'm just starting with this, and I'm specifying /data/user.tbl, and then I'm also passing the separator because separator by default is comma. So I want to override that. My file is having pipe, so that's why I'm passing pipe here, and I'm saying df equals to this, and I can have df. So when I run it, you can see we have this tabular structure, and 943 rows are there and 5 columns. So if I go here, you will find there are 5 columns, 1 2 3 4 5 columns, right? And we can see the shape, and shape will give us similar information that we just saw. And we can also get specifically like 0th index. This is a tuple, and you can retrieve values from the tuple very easily. We discussed that during the Python course. Now I am here, and I can specify df.info. So when I do df.info, it will show me the data type of various attributes. So it is integer, and this one is object. So it is automatically able to infer the types from the data, and it is also able to tell me like how many rows are there. And we can see like there is no missing data here because all columns are having 943 non-null values. So this is another interesting takeaway. Apart from that, in this you will also see the memory usage is 37 KB. And so if you want to see what is the size of this file on the disk, so we'll do ls on this particular directory. So right now we are let's say in this particular directory, like I'm just doing ls on the data directory, and you can see we have size approximately 20 KB is the size on the disk, but size in memory is much more than the size on the disk. So I wanted to show you this distinction. The size on disk is not correct indication when it comes to like the size of Pandas data frame, because we have to consider size in memory. Every data type will have its own requirements for consuming space, in the memory, so that's why it is around 37 KB. It is not 20, around 20 KB. So this is a very important takeaway, because pandas will not work when we have data size more than the size of the RAM which is available, that you have allocated to this process. So it's very important that we should understand this concept. So if you have data which is bigger than the size of memory, then you have to choose another technology like Spark SQL, which will give you data frames which can span beyond one machine, right? So this is about exploring data. So we are just understanding our data. So df.head, when you do, you can see how many records it is showing. Right now it is showing 5 records by default, but you can always say df.head and you can say 10 records I want to see. So now it is showing 10 records, and you can do df.tail. So there are so many methods through which you can do exploratory data analysis. So it's all being done, being discussed, but repeat. So whatever we are discussing right now, it's all about exploratory data analysis. We are just understanding our data. We are making sense of it. We are basically looking at various aspects of data. Once we understand it, then it will make much more sense to clean it and then finally use it for machine learning, right? So we are getting familiar with our data. So we have other methods also, like you want to retrieve the columns, you can retrieve the columns. If you want to retrieve the index, so you can retrieve. So the index is between 0 to 943 and the step is 1. And if I go back to the definition, you will see like data frames and series, they have an index. So I'm referring to the same index that we were discussing earlier, right? So now we have another method which is like you can describe. So when you do describe, then you can see it shows us the descriptive statistics of the numerical column. So these are the two numerical columns, user ID and age, and it is showing us the descriptive statistics of these two columns. We have other 3 columns also, those are categorical data. So finding average gender does not make sense, or finding average occupation does not make sense. So that's why df.describe will show you descriptive statistics of the numerical data. But in case you are interested in knowing everything, or you want to apply it for everything, all the columns, then you need to pass include all. By default it does not show categorical data or the data which is non-numeric, but if you do include all, then it will show you those things also. So now when we see like a specific column, we can say df.user ID. This is one way of looking at it, and there is another way. We can also say like user underscore ID. So when we do that, sorry, this is a name. So now you see the output is same. So there are 2 ways to refer a column in pandas. So one way is you just do dot and then column name, or you use like this. So this is helpful when you are having column with spaces or special characters. So you can just pass it within this quotes and then it will take care of that. So let's see the type of df. What is the type of df? And it is interesting that it is showing me pandas type, and when we see the type of user ID, then the type is series. So we have data frame and we have series, they both belong to pandas, and we were discussing the same thing on the whiteboard also. So now I hope you got the idea, like pandas is having 2 main data types, and series is nothing but numpy array plus index. So if you see, this is the content, this is numpy array, and this is the index, right? So we can also pick up another column. Let's say we are picking up another column, occupation, and we see this is the index and this is the content, or the actual actual series content, or you can say numpy array content, right? So this is we have. So D type is object, which is categorical data. So if you want to find out some statistics around this, so you can say mod. So mod will give us the most frequently occurring value in the data set, and we see that student is the most frequently occurring occupation in our data set. We can also find out mean of age, and this is 34.05. And if you do df.describe for specifically like age, you will see this value matches with this value, right? So these are some additional statistics related functions that I wanted to highlight, like Pandas library provide these functions. So we have other interesting things, like you want to plot this age into histogram, so you can simply say hist, and this is like showing a visualization how my users age are distributed. So this is the data distribution and how it is distributed across. So you'll say my most of the users are young and between age 20 to 40. So this is like having frequency, how many users are having this much age. So my user base is quite young, right? So now we are going to see some interesting aspects around the age attribute. So actually age is a very special attribute in ML, because like let's say we are using age for predicting salaries. So then you will find the person who is having age 28 years or 29 years, it hardly matters, like the salary will be in a similar range if we ignore the outliers. So age, you will find like people who are having age less than 20, they are hardly earning because they are students in most of the scenarios, and people who are having age more than 60, they are also not earning much, or maybe they are just getting a pension. So in between 20 to 60, most of the people earn. So that's why age is a very special attribute. So we will see like how we will treat age if we get an opportunity to train a machine learning model with this particular attribute. But for the time being, let's see some aspects around age, like how does it look like and what do we do in case we have some attribute like age. So let's say we are having df.age, and we are saying value underscore counts, and we see that there are so many people of age 30, 39 people, and there are 38 people of age 25. So like that we have in our data set. Now we have another method which is called sort underscore index. So we will use that method. So this is actual data and this is our index. So if we apply this method sort underscore index and we run it, then we are sorting this particular index, because this is an index, and this indicates actually the age and this indicates the count. So we are sorting that, and we are able to see the person, and this is like a kid, 7 years old kid, and there is only one. And we have a person who is having age 73 years, and there is only one person of that age. So this is another common way to understand the data. Maybe it does not make sense now because there are so many distinct values. There are people of different ages available in our data set. So why not we visualize it to understand it better? So for visualizing it, we will have a separate discussion on visualization, but since we are in Pandas, and in Pandas I mentioned it also provides certain capabilities of data visualization which are built on top of Matplotlib only. So I'm going to show you some basic way of visualizing this age data. So I'm just simply following the things that we had in the previous cells, and I'm just using sort underscore index, the same thing, nothing special. But after this I will use a plot method, and I will be plotting a bar chart. So I will be saying kind equals to bar, and I will say figure size is something like maybe 10 by 4, something like this, and I will say this plot that I'm having will be having X label, Y label. So let's plot it and then we'll fine tune it. So we are able to plot, and these ages are on the X axis and the frequency is there on the Y axis, and you see these are very close. So I will make some room and I will make it bigger. So now it looks better. So I increased the figure size from the X axis perspective. Y axis still looks fine. Now I can also specify some labels here. So I will be just using plt.x label, and I will be specifying some labels. For example, let's say I'm giving X label as age, and then plt.y label, is number of users or number of users, something like this. And then I can also specify some plt dot title, the overall title of this plot. So I am plotting number of users per age. So this is number of users per age, something like this. And when I run it, then you have I did not define plt, so why not we go back and we quickly define plt. So we did not even import matplotlib. Let's do one thing, like let's import pyplot as plt, and once it is done, we'll go back here to our code and we will rerun it. So we can see now we have a much cleaner and much more readable plot. And here, this is the title, this is X label, this is Y label, and this is much more easier to comprehend compared to this array or tabular structures, right? So definitely this is much more easier. So I hope you got some idea, like how do we work with the basic plotting methods within pandas. So just see, like the plot method gives us ability to plot different types of plots in pandas. So you can simply say df.plot and then question mark, and then you will see so many options are there. But right now we have chosen the bar chart, so that's why it looks like this. So I will delete it now.